Hello all. In this video session we will be discussing about files. So till now we have been using programs, and in all of these programs we are actually getting data from keyboard, and then the results were printed in the screen, right? So if we consider those programs, once the program finishes execution, every data that we fetched or got will be deleted once the program has finished execution. Okay, so these files help us to store these information. Okay, so we can say that file is used to store a collection of related information. Okay, there are different type of files like picture files, music files, video files, executable files, etc. Okay, and here we will be mainly focusing on two type of files, that is text file and binary file. In text file the data is in ASCII form, and it can be read by using editors like gedit, nano, notepad++, etc. and it will have some extensions like .text, .c, .java, etc. Okay, but in the case of binary file, all the data are in binary form, so it will be having some extensions like .bin, .exe, and these are not as easily readable as text file. Okay, so actually in case of binary file we will be writing the data in raw byte form. Okay, so remember the differences and two types of files. Now we should understand the concept of a stream. So a stream is a flow of input or output data. It may be a flow of characters, numbers, or bytes. So if the flow of data is coming to the program, then it is called input stream. Then if it is a flow of output data, then it is called output stream. Okay, till now we have used input stream from keyboard to program, and then output stream from program to monitor, but we can use other devices for input and output streams. Okay, for example, if you want to watch a movie, and if that movie is stored in this compact disc, then we can use some program like VLC to fetch those data through this input stream. So from compact disk there will be a flow of data to the program, and this flow is called input stream, and then after that it will be processed by the VLC, and it will be converted into a format so that the monitor can display all the visuals, and this flow of data from this VLC to the monitor is called the output stream. Okay. Okay, similarly, if you want to copy something to your hard disk from compact disk, then this compact disk will be providing the input stream, and this particular copying program will be outputting that particular data to the hard disk, so that will be the output stream. Okay, so if we have a program, we can have input stream from many devices, and we can output it to as much devices as required. Okay, so remember about these concepts. So we had a library of functions which is applied to perform input or output operation, and this IO library functions are defined in the header file stdio.h. Okay, now we will see different type of streams in C. There are three standard streams. First one is stdin, stands for standard input stream connected to keyboard. Okay, so this stdin is the stream in C which is actually accepting the data to the program, and then we have stdout, and this standard output stream will be actually giving the output stream. Usually it will be connected to the display. Then there is stder, which stands for standard error stream. In case of any error, the program will display the error through this particular stderr stream, and usually it is connected to display. Okay, so stdin usually connected to keyboard, and stdout and stder connected to display. Okay, so these are the three types of streams in C. Okay, so input functions like scanf and getter usually read data from stdin. That's why when we use scanf and getter, we were actually accepting the data from keyboard. And in the case of output functions like printf and putchar, usually whatever we are printing or writing inside this putchar get displayed in the screen, because these functions are normally writing to the stream std.out, which is usually connected to the display. Okay, but if we consider file, to access file, we know that in order to provide flow of data to a program, it should be connected to streams in C like stdin, stdout, or stdr. So in order to make that happen, we have to connect these files to the program. Okay, so first files need to be connected to the program. Once it is done, then the system will connect this stdin, stdout, and stdr accordingly. Okay, so now we will see what are the different steps that we have to do so that we can connect file to the program. Okay, so basically reading from or writing to a file in C requires 3 basic steps. Using these steps we can connect to the program. So first one is open the file, second one is perform all the reading and writing operations, then third one, close the file. So these are the basic 3 steps for accessing a file. Okay, so usually when we are dealing with a file, we will be using something called a file pointer. So this, using this file pointer, we will be referring to a file. Okay, so this file pointer points to a structure that actually contains information about the file. Okay, so inside stdio.h there is a library defined structure called file, which is capable of storing different information about the file. So usually to access a file, we will be creating a file pointer which is of type file, and this file pointer will be pointing to this file structure. Okay, and this file structure will be containing the information about the file. Okay, so remember about this file pointer. Okay, now first we will see how we can open a file. Okay, so for opening a file, we have to declare a file pointer. Then to open the file, we have to use the fopen function. Okay, so this is our syntax. So this file is actually the name of the structure. So every time we have, for declaring a file pointer, we have to give here file all in capital letter. Then after that, I have defined a file pointer. Now file pointer is a user given name. I have declared it as fp. Since it is a pointer, I have given star sign here. So file star fp. Then we can open a file using the function fopen. So I have given fp is equal to fopen of file name comma mode. So here we have to provide the name of the file, and here we have to provide the mode in which it has to be opened. So we have read mode, write mode, append mode, etc. So this is the normal syntax for opening a file. Okay, so if we see an example here, so file is the structure type of file. So it is file, then fp is the pointer, so star fp. Then I have given fp is equal to fopen of, then inside double quotes the name of the file. Okay, and comma, then inside double quotes I have given the mode. Okay, that means that to open demo.txt in write mode. Okay, so if it opens correctly, then its address will be, the information about the file will be stored in a structure called file, and that particular location will be returned to fp. If it fails, then null value is returned to fp. Okay, so these are the basic modes for opening files. We have read mode, that is R. So if we give double quotes inside double quotes R, then the mode will be read mode. So it means that to open an existing file for reading only, that means that if a file exists, then it will be opened. If it doesn't exist, then null value will be returned. Okay, now in case of write, open the file for writing only. Okay, so the mode used for writing mode is W, and it will open the file for writing only. If the file already exists, then it is truncated to 0 length, otherwise a new file is created. Okay, so here truncated to zero length means that if that file is already existing, then the file pointer will be pointing to the first location. That means it will be start overwriting the previous content. Okay, so in simple terms, we can say that even if that exists, those old data will be lost, and the newly written data will be only containing inside that particular file. Okay, and then we have the append mode, that is inside double quotes we have to give a. So append mode open a file for append access, that is writing at the end of the file only. So in case of append mode, if the file already exists, its initial contents are unchanged, output to the stream is appended to the end of the file. Okay, so if the file already exists, then the pointer will be pointing to the last location, and we can write data from that position. So the old data will be there, that will not be lost, and we will be writing data after that particular old date. Okay, now consider that if we are trying to open a file in append mode, and if that file doesn't exist, then what happens is that it will create a new empty file. So these are the basic three modes for opening files. So in case of read, write and append, read won't create a new file if it doesn't exist. So it is only for opening existing files. But in the case of write and append, they both will create new file if that file doesn't exist. Okay. So the difference between write and append is that write will overwrite previously written content, but in the case of append, the new data will be appended to the old date, or it will be start writing from the last position of the file. Okay, so these are the main differences in R, W and A. Then we have some other modes that we will see later. Okay, so for opening file, the statement fp equal to fopen of demo.txt comma r is given. Here this fopen function accepts two arguments, both are strings, that's why they are given inside double quotes. So this is the name of the file, and the second argument is the mode in which it is to be opened. Okay, so this would open the file demo.txt for input or reading. Okay, so the program will be reading data from this demo.txt. Then the statement fp equal to fopen of demo.txt comma w will open the file demo.txt for output or writing to the file. So the data will be written to the file demo.txt. Okay, so once the files are opened, they stay open until you close them, or till end of the program, which will close all files. Okay, so that is how the file opening works. So remember about this function fopen and the arguments. Okay, arguments or parameters. Then once we give that statement, we have to check for successful open. Okay, so once we give this particular statement, then we have to check whether this has executed or this has worked correctly or not. Okay, so if the file cannot be opened, then the value returned by the fopen function is null. Okay, so let's assume that the file demo.txt doesn't exist, and if we are trying to open it in read mode, then in that case, in read mode, as we have mentioned, if the file is not existing, then it will return a null value. Okay, and this null value will be stored in fp, and here we will be checking if fp equal to null. If that's the case, then we will be printing an error message like error opening the file, and then we'll be using this exit statement to exit from the program. Okay, so here we have given one just as a message to the operating system telling that everything didn't go well as we have planned. Okay, so exit is actually a function defined in the library header file, that is stdio.h, that you have to remember. So in order to check whether we have successfully opened a file or not, we can check the value of this file pointer fp. So if the file is not opened, then this null will be returned to this fp. So if fp equal to null, then we can say that there is some error opening the file. Okay, so this is a method for checking for successful open. Okay. Okay, now we will see how we can read from files. Okay, so we have seen these statements about how we can open a file demo.txt in read mode. Then we have seen how we can check whether it has actually opened or not. Okay, now here for reading from files we are using a function called fscanf function. So it is very much similar to scanf function. Okay, so we know about scanf function, right? So if you want to read some data to the variable, say roll number or name, we have been using this scanf statement, and then we have been using this format specifier. Then after that we have specifying the address, right? So here roll number, we will get the address of roll number providing ampersand roll number, and we will be get the address of name by just using that particular name, right? Because since it is an array, name of the array will give the starting address of the array. Okay, that's why I have just given here name. Okay, so that is the variable name or the array name which will be providing the address. So here no need to use ampersand. Okay, so the only difference with the fscanf is that we will have an f for representing this fscanf function, and the first argument is actually the pointer to the file. Okay, so this is the only difference when we are using fscanf instead of scanf. Okay, so we will be having first argument as the file pointer. Okay, so what it does is that the fscanf would read values from the file pointed by the fp and assign those values to roll number and name. So consider that if I have a file demo.txt and inside I have a value 1 and after that I have a name like Abhishek, then this 1 will be stored inside this roll number and the name, that is Abhishek, will be stored inside the variable name. Okay, that's how fscanf works. Scanf reads from the keyboard, fscanf reads from the file. Which file? That is demo.txt file. Okay, whichever file name you have given here, it will be reading data from that file or scanning data from that particular file. Okay, that's how this fscanf works. So using fscanf we can read different type of data which is stored in the file. And one thing you have to remember is that fscanf separates different data in a line based on the white space present in between them. Okay, so if I have to store this 1 and Abhishek, I should provide a space after 1. Okay, then only we can read data using this fscanf statement. Okay, that we will see when we are using the fprintf statement. For now, just understand that for reading data we can use the fscanf function. So this fscanf function will read data from file and it will give the first data to roll number and second data in that particular line to name. Okay, so that you have to remember. Then while we are reading a file, we should continue this process until the end of file is reached. Okay, so the end of file indicator informs the program when there is no more data to be processed. Okay, and we have a number of ways to test for the end of file condition, and here we will be discussing about 2 such ways. So one is to use feof function which returns a true condition or false condition based on the value in fp. Okay, so consider that we are reading data using this fscanf function. Then after reading this particular data, we can, once fp reads one data, then it will go to the next particular location. For example, here %d and %s is given. So after reading first integer and then a string array, it will point to the next location, and if that particular location is end of file. Okay, that is what feof means. So now if you observe this code here, if feof of fp, that means that whether the fp is at the end of file. Okay, this file pointer is at end of file. If it is true, then in that case it will return a non-zero value. If this fp is not pointing to the end of the file, then it will return a zero value. Okay, in that way we can check whether we have reached the end of the file. Okay, so you can use this feof function of fp to check whether fp has reached the end of file or not. If fp has reached end of file, then it will return a non-zero value. If it is not at the end of file, then it will return a zero value. Okay, so that is one method. And in the other method, we can use the value returned by the fscanf function. So I have just declared a variable status for storing the variable returned by this fscanf function. And if the value returned by this fscanf function is equal to end of file, then we can say that end of file has reached. Okay, so usually this EOF value of EOF is -1, and if this FP, once this value is red and then FP is pointing to the end of file, then it will return -1. So status will be having -1. So if we compare status and EOF, EOF is a macro which is having a value -1, then these condition will be true and we can say that end of file has encountered. Okay, so we have two methods for checking whether we have reached at the end of file. First one is a function feof of fp, and that will return a non-zero value if end of file has reached, or it will return a zero value if end is not reached. Then another way is we can check whether the value returned by fscanf is -1 or not. If it is -1 or if it is end of file. Okay, EOF means -1, then we can say that end of file has encountered. So we have two methods, feof and the function feof and EOF, the macro EOF. So using both we can check whether end of file has reached or not. So using this we can read till all the content of the file are traversed. Okay, so now we will see how we can write to files. So we have seen how we can open a file. For that we'll require a file pointer, then we have opened the file in write mode, then we have checked for successful open. So if all of these have went well, then we will be finally printing the value. Now this fprintf function is used for printing values to the file or data to the file. So it is similar to our printf function. So usually we have printf statement, then we have %d if you want to output a integer, then if we want to output a string, then we have a %s. So we will be specifying the format specifiers, then we will be giving a comma, and then we will be giving the variable name from which the data will be taken. Okay, so in case of fprintf we have one more addition, that is at the beginning we have to give the file pointer. That is the only difference, and the other difference is that it will be writing to this file instead of the output or normal output, that is screen. Okay, so I have given roll number as 1 and name as Abhishek. So once this file is opened, then what happens is that this roll number, that is 1, will be written to the file, and then there will be a horizontal tab. Then after that the value in the name, that is Abhishek, will be written to the file, and then the new line character will also be written into the file. Okay, so here we use this fprintf for writing the data to the file. Okay, so the fprintf would write the value stored in roll number and name to the file pointed by fp. Okay, one more thing that you have to remember is that after a read and write operation, this fp will be incremented, or it will go to the next particular word. Okay, so this is how we write to the files. Now after reading and writing, we should close the file, and the syntax for closing the file is fclose. Then inside that we have to give the file pointer name. Okay, so we have fclose, then it is a function which is accepting the file pointer, that is fp. So it will close the file pointed by fp. So it will close the file and release the file descriptor space and IO buffer memory. Okay, so this is what this fclose does. Okay, another thing about closing files is that closing a file is very important, especially with output files, because the output files are often buffered. So fprintf need not write to hard disk right away. Instead, it may store this data temporarily in an output buffer, and this data in output buffer will be flushed to the file in the hard disk only once in a while. So if you doesn't perform this fclose function, and if there are still some data left in this output buffer for writing to the file, then those data will be lost. For example, we can consider the safely remove feature in when we connect a pen drive to your system. So consider that we are copying some data, and due to some reasons some data were in the buffer and not transferred to your pen drive. Then in that case, if you remove it without using the safety remove, then that data will be lost. But if you give those instructions to the operating system like safety remove, then what it does is that it will flush out all the data that is in the buffer to the pen drive, so that you will get all the data returned to your pen drive. Okay. Similarly here, it is advisable that you use the fclose function, especially when you are outputting files. Okay, so these are the main things that you have to remember. Okay, now we will see how this example program works. Okay,